Welcome to Digital Toolbox. This is part 4 of the door definition tutorial, and to continue I'm going to create the swings for the left and right door. So I'm going to move over to where the buttons that create the doors are, and I'm just going to go to curve, go to primitive, and grab arc 3-point, and I'm going to copy and paste this because we're going to need two different swings. And then I'm going to need a circle. And this circle, the origin of the circle will be based on the second point of the left door. And then the radius of the circle will be the door width. Next, I need to evaluate these points at 3 points so I can create the arc. So I'm going to go to curve, go to analysis, and grab the evaluative length. I'm going to need 2 of these. I also need 2 of these for the second swing, so I'm just going to copy and paste that right now and move it down here. And then the curve to evaluate is our circles. The first length will be based on the function that we haven't used yet, is the x over 360. And right now our door is at 90 degrees, and 90 divided by 360 is 0.25, which is 0.25 of the circle. Because our length is based on 1, so 0.25 is a quarter of the way, so that's why we use x over 360. And this is going to be our first point for our arc. And then the second point will be the center between the starting point of the circle and the new point that we evaluated. So to do that, we're going to go to logic and grab a one variable expression, and we're just going to take the expression editor and type in x over 2, and the value for x will be the resultant of x over 360, and this will go into the length. So now it gives us the center between these 2 points, or an eighth of the way of the curve of the circle. That will go into B. And then C will be a point XYZ. And X will be just the door width. And this will go into C. And then I'm going to unpreview the value of lengths and the circle. So now you can see the door swing. So if we swung the door further out, the arc will follow. I'm going to unpreview this point also. And now I'm going to do the right door. So I'm going to preview that rotation, unpreview this rotation. So we need the circle, so I'm just going to copy and paste. The point for this circle we need in point XYZ. And I'm just going to put that into P right now. And for X, it's going to be the door width, and then Y is going to be the door thickness. Now unpreview this point, preview the circles. So now we need to evaluate this circle, so I'm going to put that into the evaluative buttons. And then the first point will be this point here, the second point of the door. And then for B and C, these are the points to evaluate. But the lengths, we need a function, which is going to be a one variable expression. And I'm going to give you the expression and try to explain why we need to do this. So it's 0.5, and then I decided to use 80, so it would be closest to the value that we're trying to reach. And then I just picked an arbitrary number like 3 and then subtract x. And I'm going to copy and paste this expression. And in the second expression, it's just going to be 0.5 subtract x. And then I'm going to move this over to where the x minus 360. The resultant of x over 360 will go into the values for x. And I'm going to move this back. And this will be for the lengths. preview the circle. So this give us the arc. Now, the first expression, why we picked 0.5 and a lot of zeros and 3 is because the way Grasshopper is made up, that to get the swing for the other side we have to subtract 0.5, so then the starting point is actually starting on the opposite side, because the starting point for the evaluative curves will always start in the x direction of your world plane axes. So to start on the other side we subtract 0.5. And then we added 0.0003 is because we wanted to get as close enough to this point but not touching it or overriding it. And then the other point is the point closest there. If you guys play around with these numbers, the arc will actually be on the other side and not the door swing. Just trust me on this and just use the expression. I played around with this a lot and there's no other way. But if you guys found some other way, just please email us so we get a better definition for this door for the right swing. But the swings work. So if I toggle the degree, the swing will be true. So just to make that clear, the first expression is 0.50000, as a lot of zeros, or you can go as little as 0.503 or whatever, and subtract the x. And the x is from the x over 360. And then the second expression is just 0.5 minus x. And these two evaluative points will go into the B and C of the arc 3 point. And that's how we create the left and right door swings. And thanks for watching.